Hi, welcome to our two-part series on energy. This is our second video, Kinetic Energy. Before you watch this one, you should have already watched our potential energy video, and this is our second video, Kinetic Energy. So let's get started. What you need to know by the end of this video is what kinetic energy is, what is the formula for kinetic energy, what are the units for kinetic energy, and how to solve for kinetic energy. So let's begin by first learning what kinetic energy is. Kinetic energy is the energy of an object in motion. So, there needs to be an object, whether it be a ball, a person, an animal, whatever. And it has to be in motion. This object can have any type of motion. It can have vertical movement or horizontal movement. So in this first one, we have horizontal movement. The ball is moving back and forth. There's also a little bit of vertical movement, but it's mainly horizontal. So this ball, as it moves, it has kinetic energy. Now, as this ball moves up and down, it has kinetic energy as it's moving. So as it hits the guy, it has kinetic energy. As it rolls down the hill, it also has kinetic energy. The kinetic energy of an object is dependent on the mass of the object, and this is written in kilograms, and the velocity of the object, measured in meters per second. As the mass increases, so the heavier the object is, the more kinetic energy it has. So, a feather has less kinetic energy potential than a bowling ball. A bowling ball will always have more kinetic energy than a feather. And as the velocity increases, the kinetic energy also increases. So a car going 3 meters per second has less kinetic energy than a car going 5 meters per second. So mass and velocity are two major things that influence kinetic energy. So now that we know what kinetic energy is, we can move on and figure out our formula. In order to solve for kinetic energy, we need to know our formula. And the formula is a little tricky with this one. It is a little bit more involved. Kinetic energy is 1/2 mass times velocity squared. This can be written as KE equals 1/2 mass times velocity squared, or 1/2 mv squared. Again, this is a little bit more tricky, but don't worry, we're going to help you figure this out. And to help us figure it out, we are going to bring back the triangle that we learned about in the previous video, and we're going to take a look at how to solve for things. This time we only have 3 variables, KE, M, and velocity. So, if we are solving for KE, our formula is KE equals 1/2 times mass times velocity squared. Pretty simple, straightforward, just plug and chug our mass and velocity and you get it. Now, if we were solving for our mass, it gets a little bit more tricky, but again, not too difficult. Our formula would be mass equals 2 times KE divided by our velocity squared. This comes from when we divide KE divided by our velocity squared, and when we divide by 1/2, we're really multiplying by 2. So that's where we get the 2KE. So that's how we get our mass formula if we're solving for mass. Now, there are times we'll have to solve for our velocity, and this is going to be our trickiest formula, but don't worry, we're going to get you through it. Velocity equals the square root of 2KE divided by M. Now again, this looks a little daunting, but don't worry, we'll help you through it. So, KV equals the square root, since we are squaring here, to get the opposite, we have to square root. That's where we get our square root from. 2, because we got to flip this over, KE divided by our M. So that's where we get that information from. Now that we know our formula, we can now figure out our units. Our units stay the same through our energy unit, and our unit again is the joule denoted by the J. This is going to be pretty easy, this unit. A lot of our things are going to have the joule as our energy unit. So now that we know our unit for kinetic energy is the joule, we can now go and move and solve for it. So how fast is a ball rolling if it has a kinetic energy of 696 joules and a mass of 4 kilograms? So we got a kinetic energy level and a mass. So now that we got our information, we can now draw our box and write down our givens, our KE, our mass, and our velocity. As you can see, we're not including the 1/2 in our givens because 1/2 is always going to be there. So, the first thing that we see is we have a kinetic energy of 696 joules. So I'm going to plug that in right here. Next thing is I see a mass of 4 kilograms, and that I write for our M. I do not see a velocity, so I'm going to write a question mark there, so I know that is what we are solving for. If we were to look back at our triangle, we would see our velocity equals the square root of 2ke divided by m. And we're going to rewrite that up here to make our substitution easier. And the substitution is really the hardest part now because it gets a little tricky with the order of operations. So velocity equals the square root. As you can see, I did a double parentheses to help us out. So the square root of 2 times our KE, which is 696 joules, divided by 4K. So the first thing we would do is our inner parentheses, which would be 2 times 696 joules. That would get us 1,392 joules, and we still keep that in our parentheses, and we are now going to divide 1,392 joules by our 4 kilograms, because that's our next step in the order of operations. We are still inside the parentheses, and we do our parentheses first. So when we divide, that gives us 348, and at this point, we square root our answer. And this gives us 18.65 for our velocity. So we pull that down into our answer box. V equals 18.65. 18.65. What? 18.65 meters per second. So we include our unit. So this ball with a 696 joules and a mass of 4 kilograms was moving at a velocity of 18.65 meters per second. So now that we've figured out how to solve one of the more complicated problems using this formula, we have learned what kinetic energy is, the formula for kinetic energy, the units for kinetic energy, and how to solve. Thank you for taking the time to listen, and hopefully you're ready for class tomorrow. Thank you and have a nice day.